So now we're going to cover the basic proportionality theorem. This theorem states that if a line is drawn parallel to one side of a triangle and it intersects the other two sides at two distinct points, then it divides the two sides in the same ratio. So I bolded out the main points. The point, you need to have a triangle, and there has to be a line parallel to one of the sides of the triangle. And if you have, in such a situation, then the other two sides of a triangle will be divided at the same ratio. So here's our triangle, ABC, and I'm going to draw a line DE, which is going to be parallel to BC. So according to theorem, we're going to have the line DE cut side AB and AC at the same ratio. So that means you can write out the proportion AD over DB is equal to AE over EC. And this is what we're going to prove. But to understand this proof, we need to understand triangles with equal area. So we have this triangle with base PQ. And from this base, we draw another triangle with base PQ and this other triangle with base PQ. Now notice that all three of these triangles share the same base. And also, if you draw out parallel lines, you can see that they also share the same height. In such a situation, all three of these triangles share the same area. So whenever you have triangles that share the same base and you can see that they're in between parallel lines, you can say that they have equal area. So back to our proof. And what did we want to prove? We wanted to prove that AD over DB is equal to AE over EC. So first thing I'm going to do is draw a line from C to D and B to E. Once I did this, I'm going to consider triangle ADE and triangle DEB. So triangle ADE is this one, and triangle DEB is this one. And if you've noticed, they actually share the same height, which is denoted by the white line. So I can say that the area of triangle ADE is equal to half times AD times the height, which is denoted by the white line. In the same way, the area of triangle DEB is equal to half times its base, which is DB times height. And I'm going to divide these two equations. When I do so, the halves get canceled, and so do the height, since it's the same height. And what we're left with is the area of ADE over the area of DEB is equal to AD over DB. Now, let's consider the triangle ADE and triangle DEC. So here's, again, triangle ADE, and this is triangle DEC. Similar to our last situation, these two triangles also share the same height, shown by the white line. So, again, we can write the area out, and this time, again, we're going to divide, so the halves get cancelled and the heights get cancelled, leaving us with the area of ADE over DEC is equal to AE over EC. Now, putting all that aside, let's look at triangle DEC and triangle DEB. These two triangles share the same base, which is line DE. Plus, they have the same height. As you remember earlier, we said that DE is parallel to BC, so we know that these two triangles must share the same height for that reason. With that in mind, we know now that the area of triangle DEB has to be equal to the area of triangle DEC, since they have the same height and base. And now I'm going to divide both sides of the equation by the area of triangle ADE. So when I do so, I end up with area of triangle DEB over triangle ADE is equal to area of triangle DEC over triangle ADE. And next step, I'm going to flip both of these ratios. So I'll end up with area of triangle ADE over area of triangle DEB is equal to area of triangle ADE over area of triangle DEC. And it might not make sense right now why I did this, but if you look closely, notice that this part of the equation is actually equal to something that we shown earlier. And so we know from earlier that the area of ADE and DEB is equal to AD over DB. Plus, if we look at the other side of the equation, this is the same thing as what we shown earlier. And we see that that's also equal to AE over EC. So now we have the proportion AD over DB is equal to AE over EC, which is exactly what we wanted to prove all along. So we've shown that the basic proportionality theorem is true, and it's a very helpful proof, especially when working with much more rigorous proofs. It's really important to know it and understand why it works this way. And I hope you guys find this helpful.